Let's start. Sure, let's introduce. This is going to be an hour-long presentation covering 2 projects, just so you guys know. But we'll try to take a little break in the middle, just for the sake of you guys' attention span. Brief introductions. I'm Tim Swanson.
I'm Connor White.
My name is Courtney Masters.
I'm Nate Flasher. I'm Daniel Gibson.
And we're in Visage. There's more to he's part of Visage too, but you'll see he's doing cool stuff too. And for those of you who may have somehow not heard of Envisage, we are a tool that has existed for a couple of years to help with the problem of academic planning. And we're going to talk about several of the updates that we made to our web application over this last month. But first, we're going to talk a little bit about the why, what, and how of Envisage and how we operate. So first, we're going to talk a little bit about the academic planning process as a whole, because this is something that I've spent the last several years first experiencing myself, and then researching, and then developing tools in. So there's a lot of thoughts that I have on it, and I'll try to keep it brief. But there's some pretty interesting things to think about beyond just your own perspective as students yourselves. The planning process is what determines, to a large extent, the quality of education you will have. Obviously, there are other things involved, like having good teachers actually showing up to class and things like that. But by and large, a lot of where we can determine the effectiveness of our education is in the effectiveness of the plan for our 4 years at college. And what we have here is kind of a visualization of the levels of decision-making that can influence your education. At the top level, you choose your college. That's a decision that happens one time. It's pretty important and pretty huge, and a lot of attention is given to it. But as we go down this pyramid into higher frequency decisions that affect the effectiveness of your education, we actually move further away from where attention is given. The choice you have in your major, you're going to make that once or twice, maybe a couple more times if you're a little more undecided. And the courses you're going to choose at every semester. You have to go through that course choice process. And then at the daily level, you have to decide how you're going to engage in those courses. And all of these decisions are going to make a huge difference on whether or not a student who may have like a fixed amount of intellectual ability, it's going to still make a huge difference on the education they end up walking away with. So like a big aspect of this is like you can go to a good school and still have a bad education if you do it wrong. Oh, is it working now?
Yeah, it might be a range thing.
Okay. Is it a directional thing? Okay. So the core problem that we've kind of come to conclude after these several years of investigating this is that at its root, student values are absent from the development of tools that students use. It's a pretty basic problem. When you look at tools like degree audit and the registration tools that we have to use, they're ultimately purchased by administrators. So those tools ultimately have to sell to administrators. And that's how you get usability issues that feel like obvious things that should behave differently when we use them, especially if you take a minute to think about how it could be better. They still don't exist in these tools after that have had decades of development and a lot of money thrown at them. And that results in tools that leave a lot of barriers to planning, not just like informational barriers, but emotional barriers and sometimes physical barriers that prevent students from being able to engage in creating a plan. When you come in as a freshman, you don't know much about how college works, especially if you are a minority student or a first-generation student. That's where the barriers are the tallest and where the equipment is the lowest. And that can be very problematic when a student is expected to come to their academic advising meeting and be able to tell their advisor what they're going to do for the next 4 years of college before they've even learned how college works. It's quite a problem, and that is what we seek to improve, because with these issues, we result ultimately in inhibited planning. Students will come up with a plan that accomplishes the bare minimum needed to get a degree. And that will only care about the laundry list of classes that they are told that they have to fixate on during their 4 years. And they aren't given the flexibility to think about anything else when they do academic planning. And that's a problem because there's so many more factors that should be considered when you make the decision of potentially the biggest investment you're going to make in your life, the courses that you're buying every semester. So our solution to this problem is to have an approach of good design, taking care of the tedious aspects ourselves, taking a mindset of helpfulness first, and understanding the students that use the tools. And these change our approach dramatically from that which you see in tools like Degree Audit, which even though its update on Sunday was huge, it was like a great facelift, updating it 15 years, it ultimately was just a facelift. None of the functionality has changed or become any more aware of the students that are using it. And even though we've only been developing for a year, there's already notable ways in which Envisage provides profound improvements on the planning process. At our core, the mission of Envisage is to improve both the experience and lifetime value of college students' education by encouraging and enabling them to create a plan that considers all of the important factors. And we're going to get, later in this presentation, we're going to get a little more in detail on the kinds of important factors that students should be able to consider in addition to just which classes they complete. Our vision is to ultimately enable an individualized education in the higher education system that suits each student's individual needs and passions. Our core values to accomplish this are to make students actually want to plan and to put them at the wheel and make them able to drive. Then we want to enable every student to create their own plan, which means that we're not going to put a massive paywall between the students that need it most and these good tools. And we're going to do that by creating a actually helpful free version, but still properly incentivize people towards a pro version as we think about this from an entrepreneurial perspective in the long run. And our final core value is to remain dedicated to the needs of the student. Now, there's a lot of stakeholder values that we have to consider when we build this product, and some of them are even considered prerequisite to having a viable product. If the universities aren't interested in us, we're not going to get very far. But we hold at the top the needs of the student. And that takes us to the actual product itself, Envisage Planner. And this is just a screenshot of the product that's already existed for several months now and been publicly available to all students at Taylor, over the last few months we've had several hundred students sign up. And we're just going to talk about now the J-term update that we just released yesterday to Envisage, bringing the fixes and the features that the students have asked for over the last couple of months. And as a brief overview of the next hour or so, our main features can be broken down to these 4 categories. I would encourage those of you with computers to visit envisageplanner.com right now. We don't even need a live demo because you guys can all play with it yourselves right now. It's live as of last night. So the 4 big feature adds that we've made to Envisage are the ability to visualize your course load via heat maps and bar graphs by pulling in data from Canvas. Our next feature is optimized planning workflow, specifically in the user interface, and some small fixes that have a huge benefit for students. And then third, we rebuilt our audit engine from scratch to make it more efficient and more reliable. And finally, we've been laying the groundwork for a new preference specification system that is integrating the technologies that Robert Swanson developed over his last 2 semesters of research. There's some really cool things going on with that. So now I'm going to hand it over to YouTube.
Thank you. So, as Tim said, Daniel and I worked on the heat map portion of this add-on to Envisage. And the reason why Tim specifically thought this was a really good idea was because oftentimes students have very unbalanced workloads. Some weeks are a lot heavier than others, especially for comp sci classes. You would end up having to overload on projects. A lot of them end up being due on the same day, Fridays, right for the weekend or anything like that. So being able to visualize your timeline of when your assignments are due would be very helpful for that. And then there's also a lack of communication between professors about assignment due dates. So when in one course, in two different courses, that if they don't, if the professors, if they're not communicated quite well enough, bid projects want to be due on the same exact day. And then it can just be better spaced out. And that was probably one of the tactical for both professors and students with the heat map. So the purpose specifically for students, we want them to be able to turn their assignments on time. We want them to be able to understand when to start on assignments, when things are going to be due. We want them to feel like they have a better handle on all of their courses and classes. For professors, they'll be able to see an aggregate heat map for a specific course that represents all the students in that course, but also takes into account all the other courses that those students are in, and then displays all of those assignments that they have, and then takes a heat map and integrates it based off of that. And it also takes into account, if you have a 1 credit hour course or with one person in a certain course, that should weigh a lot less versus a higher credit hour course or a course that has 20 people in it versus one person. All that is taken into account. Yeah. Oops. Oh, okay, so this is a video kind of going through our main page. So you can select your semester up there that you want to show. Right now we're toggling on and off assignments. You can also choose to show weekends or not. And we also have a weekly bar graph view. So this is another way of displaying on a weekly basis throughout this semester which weeks are going to be harder than others. So right here, you have a big workload. Here, not so much. So give you a better idea of what your timeline looks like for the semester. So this is the same page. The heat map. So we'll start over here at the top left. Trying to make sure you guys can see this slider. So this, this color will match up with a color over here, more or less. This again with more or less that color, but it's not just limited to these 3 shades of red. That just gives you an idea, as 10% represents 10% of a given credit hour, 23% represents 23% of a given credit hour, and so on. And so the darker red that it gets is the more difficult a given day will be. For example, on days where it starts you off exams or final papers or anything along those lines. On days where there's nothing or assignment, you may have no assignments or maybe just a reading assignment or something like that. And if this isn't quite easy enough to understand at first glance, by clicking this toggle over here, it went by really fast in the animation, but these assignments will disappear and the heat map will come down and take up the entire day slot on the calendar, making it much easier to see the actual heat map in your workflow that you'll be working with. I haven't quite mentioned for assignments that don't have a date, they're just down here that you can see. Yeah. So that last view is more specifically tailored for the student individual. We're now thinking more in terms of what a professor would want to get from this. The first big difference is you're able to search for a course. And the only feature, we only have working right now Canvas courses. We hope in the future to support Moodle and Blackboard as well. We'll just see where that goes. but then search for a Canvas course and Canvas course, and then that'll add on to the sidebar over here. And then for whoever's in that course, let's say you search for Dr. Nerdfla's CAUS 343 Advanced Database Systems course, all of those assignments would come up for that. But then for anybody in that class, the other classes they are also in, those classes will also appear on this side, as well as all their assignments. And in that heat map, all of that will be combined into this heat map here. So it's not just for everybody in the 343 and nothing else. It's for everybody in 343, also taking into account their other courses. If you don't want to worry, if there's a certain course that maybe you just don't want to think about, you can toggle that on and off, and that will, again, be reflected in the heat map and all the assignments. I'm probably forgetting something, but hopefully I'll be able to remember that, come back to that. So again, this is very similar to what you saw earlier. You'll be able to see this for the student or my mode view, as well as the professor view. As you can see, big projects are probably due on these days here, so being able to space out your time between these weeks before that and then the weeks after, before this comes back on, that'll be really important. Same thing here, except for the professor. So the professor will be able to see, oh, that was, okay, remembered it. When you hover over any of these squares that don't have the course there listed, it'll tell you the course. It'll tell you, again, it'll tell you the course. Same thing when you hover over these assignments too, it'll tell you the course, it'll tell you the number of credit hours of that course and more details following that course, such as like how many students are in it and other information regarding it. You can also click on any of those assignments or any of the courses, and it'll tell you more details about that course.
So I'll take over now talking about a little bit of some of the back-end work for this project, because something you may have been wondering that we've talked a little bit about for this project is, where do we actually get this assignment data from? How do we find this? And as has kind of been alluded to, we're actually getting our data for this from Canvas directly. In the past, with some Envisage stuff, we've had to manually scrape together some data to use for auditing and such. But for this project, the CSE department graciously granted us access to the Canvas CSE domain. So we were given an access token to just get data from Canvas directly, which we're very thankful for. So this here on the right is what we use to make Canvas queries. So Canvas's API uses what's called GraphQL. It's a query language used for querying data, but it's kind of in a graph format. So if you've taken data structures and algorithms, you may recall graphs a little bit. Essentially, the idea of nodes and then edges connecting different nodes. And we kind of see that structure here. So we're looking at a specific term, and we're looking at connected courses, and we look at connected assignments to those courses and such. And one really nice thing Canvas provides is an interface called GraphIQL, which is essentially like automatic query builder. So rather than having to write out this entire query by hand, we can just use this bar on the left here to select which nodes we need. So if we want courses, we can click it, but if we don't want them, we can just click them away. And you can select different properties under nodes that we want. So it made it very easy to build out the queries so we could pick exactly the data we need. And as we kind of kept moving forward on the project and finding we needed different information that we needed, made it very easy to change that scope. So the data is returned in a JSON format. You can kind of see here, it resembles pretty similar to what you get in the query. Same names, same kind of graph structure and how things are connected. So it's a very easy API to work with. I was actually very surprised at how just nice it was to use. One issue we did run into was that we needed a lot of data to actually compile the heat map. And we were finding that some of our queries were taking anywhere from 5 to even 20 seconds long to complete. And consider that this is just the Taylor CSE courses. So if we're looking at courses for an entire institution in the semester, then that could get large magnitudes longer. So our solution to this problem was to implement a caching system. So Envisage uses Google Cloud for a lot of its backend services. And one thing Google Cloud provides is a Firestore, which is essentially a cloud file storage. That's something Connor will touch on a little later. We've used it in other parts of Envisage. But specifically for here, what we do is when we go out to get data from Canvas, we'll actually cache it in our Google Cloud Firestore. So rather than having to wait 5 to even 20 seconds for a query, we can simply just go get what we have in the cache, return that, and complete the query in under a second. It's a very significant improvement to efficiency. And one problem with that is we need to make sure the data is up to date. So you have a couple ways we do that. One, we just have an automatic update trigger that runs once a day. So every day at midnight, it will go out and grab new data for the cache. Another trigger we have is that every time the interface makes a request to the API for Canvas data, the API will go grab the data from the cache. Excuse me. But it will also check and see how old that data is. And if the data is older than a certain age, say 5 minutes, it will create a new thread to go update that data. One decision we made there was to return the old data rather than waiting for the new data to come in and using that. We made this decision because we figured that in terms of the scope of the data we're actually working with, it's just assignments that professors are manually creating in courses. We decided that it would be very rare that there would be a time where maybe a user was requesting data that was out of date that would actually have a major impact on it. So we figured that it would be better to focus on the efficiency for that, work with maybe slightly out of date data, and the cache will be updated for the next time the user makes a request. Yeah, it's a very nice system. You can kind of see in this diagram here just the overall flow of data through this part, through Envisage. So the UI makes a request to the API, which goes out and checks data in the cache. But if the data isn't in the cache, it will then go and grab it from Canvas as well. And it will grab all that data and eventually send it back to the UI. But before we send it to the UI, we have to actually parse through our data. Canvas returns a lot of useful data, but we only want to return specific things to the front end. There's only certain things we need for the heat map. So one thing we do that we like to parse through is a list of students who are enrolled in the course. That's kind of how we match up like checking a student's actual courses. So the API is provided with the name of the student whose courses we're searching for. And currently our best system for that is just a name match. So we check through the students enrolled in a certain course, and if the name matches, then we add that course to the list of courses we return. It's certainly not a perfect system because, say, in Envisage, you have someone named Tim Swanson, and in Canvas, their name is Timothy Swanson. And the names aren't going to match, and you're going to be missing those courses. One thing we want to implement in the future is actually using some of Canvas's OAuth systems. So essentially, the idea is you can, through Envisage, sign in with your Canvas account, and then Envisage is automatically able to use that authentication to go grab data from Canvas directly without having to do some arbitrary name matching. That's one thing we hope to implement in the future, but wasn't in the scope of this project. Another thing we have to do is actually figure out which course we're looking for. Some of our queries are based on the course name, like the roster view is looking for data about a specific course. And this can also be a bit arbitrary because in Canvas, the course code isn't necessarily set as a specific thing. Some courses in Canvas are set as COS 382, whereas some are a longer string with a more complex string of information associated with it. It's just whatever scheme the professor decides to use. So our current system for checking that course is just using a regular expression, pulling out the important bits from it. It's not a perfect system, There's a game jam course in Canvas, and our system is currently pulling that down, even though it's not an actual course, but it matches the regular expression. So we want to make improvements on that in the future as well, to find a rudimentary way to, or more robust way to actually guarantee we're getting good course information. But overall, it works fairly well. And our data parsing is pretty complete as of now. We have several different queries we make because we have several different views that need different kinds of information. So like the student semester view uses slightly different information than the roster view, which actually goes out and pulls from multiple courses based on data from one course. So now that we actually have provided the data to the front end, we've provided a list of courses and their associated assignments, we actually have to score the assignments so we can plug them into the heat map. So the scores for assignments are calculated on a daily basis. So what we do is each assignment is given a score. That score is based on this formula here. So what we're able to do is with this assignment points divided by assignment group points times the assignment group weight is essentially a long way of saying we calculate the impact of an individual assignment on your overall course grade. So say you have a quiz that's worth 50% of your quiz grade, and quiz grades are worth 10% of your course grade, then that specific quiz is going to be worth 5% of your course grade overall. We also multiply this by the number of credit hours that the course is worth, because if you have an assignment that's worth 5% of your overall grade, but the class is only 1 credit hour, that's going to be less important than, say, a class that's worth 2% of your grade, but it's actually 4 credit hours. On a credit basis, that's going to have a bigger impact on your overall GPA and your performance. So that's kind of the factors we use to calculate the score of an assignment. One thing about it is it's very due date based, and an assignment only really has an impact on the day it's due. One thing we want to expand on in the future, which would be really cool, is actually taking a look at when a student might actually work on that assignment. So factoring in not only when the assignment is due, but when a student's actually going to be working on it, which would provide even more of a productivity tool and be something even more useful for students. One final thing I'll note here is that the roster view of the heat map also takes into account the number of students in a course. So say we're looking at database systems, which has 20 people in the class. And one class that's associated is data communications. Only one person from database systems is in data communications. That's going to have less impact than a class that has 10 people in them. We take that into account in the scoring as well, because that's just kind of what you're thinking about in the context of that main class.
Where would that fit into your formula, if I could interrupt you?
That's just multiplied on the end. We multiply the ratio of number of students that are in both courses divided by number of students in the main courses.
The one really fun problem that comes up when we have to figure out how to score assignments is how do you work with incomplete data? Because let's face it, not all professors put in all the assignments on the first day of class. And the problem that comes up with that is when we get this assignment group points value, which is the number of total points possible for, say, like the number of total points you can get in all of the tests you're going to take for a class. That's what an assignment group is. If there's only one test in there so far, but there will actually be several more later, Envisage might weight that first test, like say tests are worth 60% of your grade, and you've only had the first test, Envisage is going to think that's worth 60% of your grade, when in reality it might only be worth like 20% or 10% of your grade. So we had to figure out how to work on making predictions about this to have a lot more informed of weighting. And this was a really fun project, so I asked Daniel to let me do the math on this. It was a fun Friday evening thing. So basically the way that this worked was what we needed to generate, again, was that the group points value for a full semester given only the data of a partial semester. So the way that I did that was by adding into the code that we already have that would iterate through each assignment in a given group, and and it would iterate through them in chronological order. So these represent assignments here. And we would track what I call date delta, the amount of time between assignments. So basically I'm asking myself, how much time, like how frequently are assignments in this group assigned? And what I do is I generate a average frequency there. It's actually a weighted average. So this average date delta will take the most recent delta into consideration twice as much as the next most recent. That way, if a professor starts making changes to their assignment patterns throughout the semester, Envisage will adapt more quickly to those changes. And with that date delta, when we hit the last assignment that's been actually assigned in Canvas, we calculate the amount of time remaining in the semester, which is just the due date, the time between the due date and what Taylor in their database has told us the end of the semester is. And we simply divide that by the average date delta, because that's going to tell us how many more assignments are going to fit in that time. And with that number, we can just multiply it by the average number of points possible in the assignments we've looked at so far, and add that to the actual known assignment group points. And now we have a predicted group points. And with that, we're actually able to generate a fairly accurate number. When I was developing this last week, we could only work with complete data because there's no ongoing Canvas courses during this J term. So what I did was I subtracted data from a known term and looked at the percentages that we generated then. And after debugging it, we were able to get weight scores within just a few percent of the actual, like when all is said and done, how much it is worth. And when you're talking about 15% of a credit hour versus 18% of a credit hour, those are functionally the same thing in how you would respond. So we were able to get, theoretically, we were able to get predicted data to be just as accurate as data with hindsight. But ultimately, we're all going to find out next semester when we actually start getting some Canvas courses. And it's probably going to be wrong for the first week or two, unless assignments, the professors put a few assignments in. But what I'm excited for is once we start getting a couple weeks in. This screenshot right here is a little bit of an aside. This is the core code for the algorithm that does the actual stuff right here. And as I was writing the code, I have a browser extension in VS Code called GitHub Copilot, which is code completion on steroids. It literally will make requests to a neural network that has been trained on all of Stack Overflow and every public repository in the world, and is incredibly intelligent. And it gave me this suggestion for the core code, and I only had to make 2 changes to like the data model, not even the algorithm itself. It was insane, so I had to take a screenshot of it. Wow. Yeah, machine learning is getting pretty good. Anyways, back to you.
Yeah, so we've talked about a lot of the math that's kind of gone into generating the scores. And there's a little more that we'll touch on quickly. So one issue that we have is that a score for a day could be theoretically as high as infinity. And we needed a way to transform that into something that we can actually use to generate the opacity for an actual day on the calendar. So you're able to use this function here to just kind of normalize it to a range to a value in the range of 0 and 1. Works very well. One thing that we found is that there's a bit of an odd curve here. So one feature that we implemented was this threshold here. So you may have noticed this slider earlier. Essentially what this does is as you slide it up or down, it kind of slides the range that gets used on this function. And the idea there is to just give the user some more control over the visual distinction of days. So as you increase the slider, these numbers will change here. The actual shades of these colors will stay the same because what happens is the kind of weight, the amount of a credit hour that's represented by a certain shade is changing, not necessarily the shade itself. It's a very kind of pro feature. It's not something that we necessarily anticipate a lot of users using, but if there's maybe a student who really wants to see in depth into how their assignments are structured, we wanted to provide that capability as well. One other issue that we found was that in order to generate these values here, we actually had to reverse our function. In the past, what we've been doing is from a score, we're generating an opacity. now, because these actual shades are hard set, we need to generate we need to use the score to generate, we need to use the opacity to generate a score. So this was fun because I have a mathematics minor, so I got to use it a little bit here. So I just calculated the inverse of the function. There is a negative square root in there, but in practice, we found that because we're only working with values between 0 and 1, it doesn't have a practical impact on how the application actually uses the math. And we do have a brute force algorithm to work around it if we find that that does become an issue. So yeah, I think that about wraps up what we've worked with on the heat map. Yeah.
Did you guys develop this function yourself, or did you find somewhere that did a threshold function somewhere?
The function to convert score to opacity was, Rob, didn't you give us that?
This is kind of a messy version of what I did.
Some of the work Rob did for PSL involved a lot of mapping, like theoretically, like infinite values, like compressing values into like a single window. So having been taught, like been shown that when we were working on PSL, which I'll get to, gave us a function similar to what we used to map this range.
So you were able to use another student's research to further your project. Very good.
Yeah, and that's something we could maybe experiment with more to see if there's something that works a little better. But yeah, our goal overall was to try and solve this problem of just students having just unbalanced workloads being dumped with tons of projects and assignments on 1 week, and maybe that information not always getting conveyed super well to professors. So we wanted to kind of bridge that gap to help students and professors have a better understanding of what the reality is of what students are actually dealing with their workloads. And I think we built a really cool and intuitive tool to kind of demonstrate that.
So yeah, just to spit off some challenges that we had through the process really quick. The design, we didn't really have an idea of what we wanted the UI to look like coming into it. So it was kind of like trial and error as we went. But as we were going, we spit out some calendars and said those, we didn't want those. And yeah, it was just a trial and error process basically for what the UI ended up looking like. And then toggle bugs we came into a pre-existing code base, more specifically Corey, Daniel, and I. Connor and Tim have been in it for a while, but basically there was a lot of pre-existing code we had to work with, and we did some copy and pasting from one page to another, and there ended up being a lot of bugs that came along with that. And so we had to do a deep dive into finding out what code we weren't using versus what code we were. But anyway, there were a lot of bugs that came from working with that pre-existing code, not sure what code did what.
Yeah, and then on the API side, it was just working with a lot of layers because we're working with pre-existing envisage code on the front end and the back end, and also developing new things on the back end, and having to work with Canvas, just kind of working through all these layers. It could be a lot to manage at one point, but it was a good experience in just being able to manage a very big tech stack in that sense. Yeah, we have some future plans for this that we've talked about a little bit. We would really love to be able to use Blackboard and Moodle data. Right now, we can only use computer science courses or courses that happen to be in Canvas. So we'd love to be able to access courses that are across the university. Identity verification is kind of that idea of signing into Canvas through Envisage and getting very student-specific data. That will both help to ensure you're getting accurate information about you and allows us to provide more specific information tailored to a student. There's some other features we would like to add as well, generalized course charts. So when you're looking at a course, you can get an overview of what the semester is going to look like. So you can just get a sense of which weeks are going to be heavy in that semester. And just more kind of small features as well. One thing we would like to implement at some point is the ability to actually drag and drop a due date onto a different part of the calendar so you can experiment with how changing the due date of an assignment affects the overall workload of the semester. Yeah, that kind of wraps up the work we've done on the heat mapping. And now we're going to move to Courtney.
Yeah, you're about to see me and Connor do the fastest presentation you've ever, no, I'm just kidding. All right, so now let's move to the front end. Basically, what we wanted to do was Envisage did some user testing earlier. They got a lot of feedback, so I wanted to kind of help implement some of that. Some of the challenges for me were jumping into a code base I'd never worked in before. A lot of the work that I did was modifying things that were already there and not really building them in the first place. And also jumping from little thing to little thing. If you've worked in UI, you know, like, oh, this thing's only going to take me an hour. No, it takes way longer because something goes wrong. And then balancing the attention to detail, making sure something is seamless versus we want to keep moving. We want to keep doing the things that are going to help other people move with what they're doing as well on our timeline. Okay, so one of the things that I did and I worked with was course confidence. And basically that means how can we tell the user when we think a course is going to be offered? Because when you're trying to plan, it's super helpful to know, okay, I want to take Cause 121. When is that offered? Usually in the spring or something like that. So there's 3 different ways that this is done throughout Envisage. One is that when you're dragging a course, it's going to light up where we think it's going to be offered. It doesn't prevent the user from moving it anywhere. It just kind of gently tells them, hey, maybe you should move it here. It also gives you guidance when you're choosing a course for a specific term. So let's say I want to add a course to fall 2021. I'm trying to get all the courses that I'm going to take then. I click on add course and there's a little icon on the side, it'll show later, that tells you, hey, this isn't usually offered here. Sometimes it's offered here, or yes, we think it's going to be offered here. If that course is already scheduled and we know for sure it's either going to be green or red, sometimes there's a yellow one, and that's for, hey, based on past data, sometimes it's offered here, but we really can't tell you for sure. And right here you can see if you click on a course, this is a course dialog, gives you a lot of information on a course, and it says course typically offered in the fall or spring. So that's just something super helpful when you're trying to plan your schedule. And here's a short demo video of you dragging a course and it lights up blue where we think it's going to be offered. And then for a specific term, you're clicking on it, you're going to add a course. No, these aren't usually offered. If you hover over it, it'll say course not typically offered in this term. There's a yellow one. We don't really know if it's going to be offered in this term or not. We don't want to say for sure yes or no. The green check mark says yes, this is usually offered in this term. Either it's literally already scheduled for that term, or based on past data, we think it's going to be, or we're pretty sure. So another thing that got updated is the browse course filter. Obviously something you want to be able to do with Envisage is search for a course. And so this is a term selector. You can search for courses just in fall 2021. So you might have noticed on the side, it gives you a lot less courses. But also it used to download the entire course catalog every time you searched. It took a long time. So just to make it a little bit more efficient, it got switched to expansion panels instead of the data table that it used to use. Another thing is you want to be able to share your plan. Maybe you're really proud of your plan. You want to be able to send it to a friend. You want to be able to publish it, maybe for anyone who has an Envisage account to be able to browse through. So this is a place where you can share your plan. Just generates a link with the base URL. It marks it as public if you want it to be published, and then it has your plan ID on it. You can either email it, that was already there, but this is just, you can copy the link, send it to your friend, and you can open it in a public view that you don't need to have an Envisage account to look at, but maybe you need an Envisage account if you want to go in and modify it as your own plan or something like that. I'm going super fast. If you think of a question, feel free to save it for the end. This is the public plan view. This is if someone just sent you a plan, you don't have an Envisage account, but you want to be able to look at it. It has just basic information. We don't have all the data yet, so the owner wouldn't really look like that, but it would say like Courtney Masters or something like that. But it's just a little bit of a simplified view of like maybe the plan that you have as an Envisage user. So there's nowhere to like open any menus or anything. You can still click on a course and see that information there. But maybe I want to send my plan to Connor because my plan is super great or whatever, and he can open it up and look at it even if he doesn't have an Envisage account or doesn't want to log in. And then if you want to publish it and you want to be able to browse it, this is a huge draw to Envisage in general, is if you publish your plan, you can look at all this list of plans. You can filter them by your major or something like that, or the name. This isn't completely finished either because obviously we don't want to show anyone, the user, looking like that. It's supposed to have their name. So it would show just basic information. You'd be able to click on it and see that whole plan. But the basic information, the name, what years it's for, what the majors are, or the areas of study, and then what percentage of your plan it's completing. And then, yeah, you can favorite them, stuff like that. So that's basically just like a starting point. The data's not all there to get that completely working. And
All right, so I'm going to share with you guys a little bit of the smorgasbord of stuff that I worked on over this past month. So the first thing that I worked on was revamping the audit engine, Audit 2.0. So I originally made the audit engine in the last 2.5 weeks of the summer, right before we launched, and it was kind of a super intimidating task, like making an audit's really hard. As you guys can see, degree audits even struggling making a good audit. So I tried throwing a bunch of code together in a horrible way in 2.5 weeks and created a disaster of an audit engine. And there was bugs everywhere. It would overflow. The numbers would get like crossed and start like matching each other for planned and completed. So it was just a mess. Tim was getting on me about it all the time. So I was like, you know what, I'm gonna make this from scratch. So I went from, I think, 1,600 lines of code to like 600 lines of code, just cleaning up so much. I think it had 9 to 6 nested for loops originally, down to 3. So it was cleaned up a lot. It was significantly faster. It's way more accurate. And it's something I'm actually kind of proud of, where before I'm like, that's cool, but I somehow made something, but I have no idea how that works. And now if somebody would, I could actually tell you guys what was happening as I was walking through the code. So Audit 2.0 now exists, should be way more accurate, and it should help people with their planning. The next thing, a big thing that I worked on over this semester was the course section predictor, the thing Courtney was kind of just talking about. So we had to do something to predict when these courses would be offered and what semesters they would be offered. So we did some fun math problems with that. So first we would get all the courses from Taylor, and then we would get a ton of section history from them. And then we would pretty much iterate through all those courses and then like start doing this math equation right here, which to sum it all up is the closer that semester is to now, the more that weight affects the percentage. So like if it was fall 2020, it has way more value than it being fall 2012. So like if it's 2020, if it's offered 2020, 2019, 2018, that means we're going to predict it's probably going to be offered in 2021, 2022. So as you can see, these are kind of like the predictions, the little like math graph that we have up here. And then with those numbers, we'll get certain numbers between 0 and 1, and the closer it is to 1 is how we go between the probabilities of yes, this is probably offered, to maybe, to absolutely not, definitely not going to be offered. And then that information is sent to Courtney in the front end and Tim, and then they did the fun little colors and stuff that front end developers do. And then with all of that, so we used Google Cloud Buckets for a lot of our data storage, caching large amounts of data. So Daniel talked a little bit about it before, and I'll kind of go slightly more in depth. So with the course info prediction calculations, so Daniel said their Canvas request took 20 seconds. This one took 3 or 4 minutes. So there's no way a user would ever wait 4 minutes for a request to finish. So we would do, I think it was, I don't know, I told you, Professor earlier, it was like 11 megabytes or 90, something crazy like that. So it was a huge request. So we didn't want people to be waiting on that. So we cached in cloud storage. So what cloud storage is a NoSQL, like, I don't want to say document, it's a file system. It's a file system on the cloud that you can easily access from the front end or back end very fast. So it is something that Google Cloud offers through cloud storage, Firestore, Fire storage buckets, and then there's also real-time databases. So they're super cool, super simple. And then we do the same thing with the course info as we did with the Canvas data. Is if the data is old enough, we will update it, but we will also send the old information first before we update it, so the user does not have to wait 3 minutes for that to happen. And the few things that we use cloud storage for is, like, originally what a lot of people use it for, like fire storage, would be avatars. Like if you want to not really have a huge backend, you can just store avatars, so that's saved to the user. But we have used it for the course info, the Canvas data, a few other things like notes, and also we are now going to start using not cloud storage, but a real-time database, which is kind of similar to cloud storages, for PSL, which Tim will introduce.
Awesome. So this is our fourth and final feature that we're going to talk about. Preference specification language, again, is the research that Robert did over the last year, originally with the intent of building a plan generator for Envisage, but then we ended up tapping into a whole new opportunity with the work he did here. So first, we're going to talk a little bit more like higher level about the whole notion of academic planning in higher education itself. So currently, planning your college career is more about your graduation laundry list. And that's about that big long list of things that Degree Audit shows you that you just got to check off. You got to take this course, you got to take this course, you got to get this many upper division hours, which apparently now you can't see anymore in Degree Audit, which is unfortunate. But there are so many other factors at play when a student is trying to figure out when they should take their classes, what classes they should take, their majors, etc. Some of those might be their personal interest in the course itself, and choosing the courses that are best for them within the choices that they're afforded for a major. Taking courses with their friends at favorable hours of the day, not 8 a.m., with preferred instructors if they have them, timing and ordering courses such that they can make the most out of them, et cetera, et cetera. There's a lot of other things going on, and ultimately those are like covered when Degree Audit gives you a percentage, that percentage that tells you how good you're doing. Some of the work we did in looking at PSL this January, Robert and I, was just taking a step back and looking at like how could we change the way that we understand college and what we are trying to accomplish with it. And we came up with 3 new terms that we want to introduce to the way you should think about your college planning or future freshmen. First, you have the idea of an objective in the middle. This is the core. An objective would, like, for example, a major is an objective. You want to graduate with graphic design. But another kind of objective might be that you want to graduate in 3 years, or that you want to take classes with people you like, or that you want to learn Chinese. These are all objectives that you have. And what that means is this is what you want to take out of the 4 years of your life you put into college and all of that money. The objective items are the individual ways in which you meet those objectives. And those are specifically divided into requirements and preferences. So a requirement is kind of the stuff that Degree Audit already talks about, except that you can express more things than just, I want to take this class. Maybe I want to require that I don't have a class conflict with my classes in my cross-country schedule or something like that. But then you also have preferences. I prefer to not take 8 a.m.s, and I strongly prefer to not take 8 a.m.s. And you can specify the intensity with which you prefer something. And that, while a requirement will thumbs up or thumbs down, it's like a Boolean value, a preference will influence a score of a plan so that you can know how well a plan scores against your objectives. Specifically, your objective set, which is just the set of objectives you have in one box that you can evaluate plans against. So if I have if this is my objective set, what I can do is I can have Envisage just recommend to me plans that have been published that score well on my objective set. In the future, we hope to even add the ability to generate plans based off of the items of your objective set. And what's really cool is that you can then share either objectives or entire objective sets with other students who may be less familiar with the kinds of things that they should want to do. So these are things that we're putting, as we build systems that will host this, we're making sure that they are very shareable and very collaborative. So with that high-level thinking about a new way of thinking about college, let's bring in PSL, which I'll try to overview pretty quickly, because Robert already gave a half-hour presentation on it that you can watch if you want, if he wants to let you. But essentially, PSL currently looks like this. It's a coding language that Robert made, essentially, where you can tell Envisage what you want your plan to look like, and it will output a yes, no, and a score on it. It's capable of running up to hundreds of evaluations or thousands of evaluations per second. And we're planning on adding a user interface on top of this so that non-computer scientists could use this feature. Robert actually just yesterday finished making a JSON form of this, and JSON is pretty easy to convert into a UI. And we're going to have that actually be a live database such that if 2 people are editing the same PSL, it'll reflect the changes across those computers, just like Google Docs would. So the January work we did specifically for PSL was to evaluate if it was something we should do, to cast that vision that I just gave you, to integrate it into our system, So that involved Robert building an API wrapper around he built it in Java, and we're using JavaScript. So he had to build a totally separate API wrapper using the Spark framework. And then I had to figure out how we would integrate that into our current system. And then we had to finally figure out how to deploy that API into our existing system such that they could communicate with each other. And this is kind of the flow chart that is the data model that we are currently still in the process of setting up. The Envisage UI API and database already existed, but we're now adding a real-time database to store the PSL, and Robert's API will just pull from there, and then it'll spit audits back out to our UI. This is a whiteboard Robert and I did of what the UI for this might potentially look like, fitting within our current, this is what audit currently looks like, and we just figured out a way to make the current audit view in the future display PSL in a very easy to understand way. So this is something that I'll probably implement in the next semester. This is a little bit of, I'll skip it. So yeah, our goals beyond this point are to finish integrating into Envisage, create that UI, ultimately reach the level of reliability that we can use PSL as our new source of truth on areas of study and on the audit, and then finally to start generating and recommending plans based on the audit. Okay, so now I'm going to do a pretty quick overview of what it was like to work at Envisage this month, and a lot of cool tools we used. Our technology, or our workspace tools, feature Notion, VS Code, and some of these other tools, Toggle Track and Desmos were very helpful, as well as some things already mentioned. Our first week involved a lot of planning, but also we were surprisingly able to start implementing our features relatively quickly and getting data in. Our technology stack is huge, but here is a summary of some of the technologies we use and the ones that were most relevant during this month. And really the theme of this slide was that there was a lot to learn for those that were being onboarded into the system. And it's remarkable that they got any work done this month because it took a while just to figure out what was going on. Usually when you're being onboarded into like a pre-existing company, you're given like a month at minimum to be onboarded. And with Senior Project, they had to actually produce features. So props to them. We used Notion as our workflow core for our task management system, for storing our notes, for giving us a calendar to do things. This was my view where I could just assign tasks to each person by creating a new item. And the great thing about Notion is that everything's a page that you can open up. So this to-do was also something that they could just open up the to-do. Go a little bit faster. These are some of the fun Notion views that I had a lot of fun making. I'm going to skip our development flow. The process of launching to production, which we went through over the last week, was a process of taking features that were working and rigorously testing them to achieve that polish, to make sure the user experience was as flawless as we could achieve before we merged our development branch into our main and launched into production yesterday, after which we found several bugs that we had to fix. And by last night, we had it fully executed. Half my job this month was management, and as a quick overview, what that looked like for me was taking a lot of the roles that happen in agile development. I was the product owner. I made all the decisions about how the project should behave, but also the Scrum Master, quality assurance, and senior developer. So I was, as I say, juggling a lot of hats. And finally, the impact of the work that we did this month. We developed a workflow for a larger team. This is the first time that Envisage has been a month of 5 people or 6 people, including Robert, all collaborating together, doing separate things that we had to still somehow orchestrate together. So it was a proof of concept that Envisage could be viable at that size. And we also expanded the scope of, we first improved the ability of Envisage to do well the scope that it was at the launch of our beta, but also extended the scope with PSL and load balancing. The planning workflow for students starting from scratch is estimated to be now 2 times faster due to that simple feature of being able to, as you drag from the staging area, instantly know exactly what your options are. And other things that I don't have time for. Thank you guys for listening. Exactly 1 hour. Wow. 2 seconds is there.
Any questions?
Yes.
So 2 questions. One, was 96 an exaggeration, or did you actually have 96 folders?
9.
Oh, 926.
926.
Yeah. Still
What?
Yeah.
Okay, cool. My second real question is, back when it's talking about the load balancing for a week view, their percentages, I was not tracking with what the percentages were for like each week.
Percent of a credit hour. So that week determined 30% of a credit hour. So you have 17 credit hours if you're taking a 17-hour semester.
So all those percentages would add up to.
Then theoretically, the number of credits of the class, like technically not the number of classes you're taking because it's only Canvas, but yes, it would add up to however many credits are on there.
Yeah. And when doing some user testing, one thing one of our testers suggested was having a view where you can also just look at like the sort of assignment score for that. So you can look at, so if you don't necessarily want to standardize it to a credit hour, you can look at how much impact that might actually have on.
Yeah.
So that's something we might try.
Or like a percentage of the total amount of points to earn in the semester, so that everything just adds up to 100. That is simple.
Okay. Yeah, because that's, I was looking at, I was trying to make it add up to 100. I was like, that's not.
Yeah. Yeah, totally.
I was curious with the heat map folks, does Canvas require assignments to be grouped? And if not, how do you cope with that aspect of what's missing?
Yeah, so from what I can tell, we mostly worked with courses that did have assignment groups. Even if it's not necessarily in a grouping, all the assignments are still going to be in a grouping, and it might just be called assignments or something. They're still all going to be under that. That gets a little more tricky because they're also not required to have a group weight. That's something we might think about in the future, is focusing on, okay, maybe if there isn't a group weight, maybe just standardizing this to just assignments and raw point value.
With the classes that have happened in the last couple of years that we were looking at so far, the numbers we've been able to cover, like generate at least reasonable numbers for all of the classes that the CC department's got.
You mentioned that the plans would be like shareable, like
Yeah.
And that your plan would be maybe compared to other people's plans.
Yes.
Maybe is there going to be like a feature where either everyone is opted in, or you can opt into, this is my plan for cybersecurity major, no minor.
Yeah. That's what publishing a plan
And
is.
then you're publishing it,
Yeah.
and then it's available to anyone, and then can they see that plan, or is it just going to be compared to in the background for like your?
Oh yeah, we have it. The page that Courtney showed is a place where you can browse all courses that have ever been published, and more importantly, you can search, because eventually that list is going to get too long to scroll through it. So we're just going to, but yes, there's the ability to find any published plan.
Okay.
Yeah. But then, like when it comes to plan sharing, think what you can do with Google Doc, and we basically model that behavior, except extending on that the ability to, if you want, publish it globally. Yes.
With your predicting assignments that haven't been fully assigned yet, and I was wondering if there were countermeasures for the disruptions holidays might introduce, so like spring break or like Easter, where things might change a little if we have like a bunch of 40 weeks or something.
Spring break is probably the biggest thing. Like, it's possible that spring break would result in noticeable changes. Single day changes would probably just, like, if it's off by a week, that's going to change the percentage a little bit. But the most important thing would be that, like, something that should be under 10% would stay under 10%. Something that should be like 30% would stay around 30%. So the answer is no. There is no accounting for that. And my guess, and I can only say it's a guess, is that it won't matter in the large run, but ultimately we'll find out this next semester. That's what we'll find out.
One more question.
I noticed that Connor and Daniel were both talking about like data caching, but I think Connor, you said like Firebase or
Firestore and bucket storage.
yeah, bucket. Is that like the same thing?
So there is Firestore, and there's Firebase buckets, and there's Google Cloud Storage buckets. Google Cloud Storage buckets and Firebase buckets are technically the same thing now, because Google owns Firebase.
Right.
And there's Firestore, which we use more for like storing users and their like avatars and stuff. And then there's the buckets where it's like, I'm just gonna store some files in there.
Okay.
They're all pretty similar, but they're different things. And there's even more stuff in that, but
It's like block versus object storage.
I kind of tell you.
That would be the
Probably don't
difference
work.
between Firestore and a real-time